Hello everybody, welcome into another lesson. So today we are going to talk about infinite geometric series. Now, last lesson we talked about finite geometric series where we always had a finite answer. Now, an infinite geometric series, you only can get a finite answer under the condition that the absolute value of your common ratio is less than 1. If it's greater than or equal to 1, it'll diverge. And the sum of that formula, the formula for the sum is just simply your first term divided by 1 minus your common ratio. Well, okay. Let's derive it from the formula for the sum of a finite series. So we know the sum of a finite series, of course, is going to be a sub 1 times 1 minus r to the n all over 1 minus r, right? Well, let's say our common ratio is 1/2. If I take 1/2 to the second power, right, I get 1/4. Let's say I take 1/2 to the 10th power. If I take 1/2 to the 10th power, let me see what 2 to the 10th is. Two to the 10th is 1024, so I'll end up getting 1 over 1024. And let's do another one. Let's say I take 1 over 2 to the 20th power. What would I get at that time? So I'm going to take 2 to the 20th power. I would end up getting 1 over 1,048,576. As you see, the higher and higher powers I keep taking this 1/2 to, I actually get smaller and smaller numbers. So the idea is if I take 1/2, raise it infinitely, it's going to get close to 0 at some point, right? We're going to get infinitely close to 0. If we were to graph that as a function, 1/2 to the x power, we would be able to illustrate that the higher values I put in for x, it gets infinitely closer and closer to 0. And in theory, we're actually previewing the limits section of this course in early Calculus 1 because that's also how a limit works. But the idea is then, eventually this would go to 0. So if I take the sum of the infinite series, we're just going to have a sub 1 times 1 minus 0 all over 1 minus r, therefore giving me my sum to be a sub 1 times 1 over 1 minus r, which would just be a sub 1 over 1 minus r. That's how we derive the formula for the infinite series. So that's where the formula for the infinite series comes from. It actually comes from the finite series. But let's say I have my ratio is 1. Well, if my ratio is 1, I'm just going to keep adding 1 plus 1 plus 1 plus 1 plus 1 plus dot 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 till kingdom come. We're never going to converge to a finite number. It's going to diverge to infinity. It's just going to keep going up and up. And certainly the same is true if my ratio is greater than 1. That's going to keep happening. That is why this formula only works if your absolute value of your common ratio is less than 1. So let's go ahead and get into some examples here. So I have this infinite geometric series where you have 8 plus 6 plus 9 halves plus 27 eighths, and it just keeps going infinitely. we need to determine what is the common ratio, and are we going to be able to do anything with this? Well, let's find the common ratio. The common ratio, we could take the second term, divide it by the first term. Well, the second term is 6, the first term is 8, we get a common ratio of 3/4. And in fact, it's the same between all the terms. So we've determined the common ratio is 3/4. 3/4 is certainly less than 1, so yes, we are going to be able to get a sum. And our first term is 8. So we can definitely get a finite answer for this infinite series. The good news is, for an infinite series, we don't have to bother trying to convert this into sequence terms, because all we need to know are the a sub 1 and the r. We don't need to know the n, or how many terms, because this is an infinite series. So in this case, the sum of this particular series from n equals 1 to infinity now we can put this into a sequence just for good measure. That's going to equal our first term of 8 times our common ratio of 3/4 to the n minus 1. The sum of this infinite series, that's going to equal this a sub 1 over 1 minus r. Well, a sub 1 is 8 all over 1 minus 3/4. That's simply going to equal 8 all over 1/4. Got a complex fraction, so this will be 8 over 1 times 4 over 1, which would just give us 32. Now, here's the thing. We'll never technically reach 32. We'll get infinitely closer and closer to a sum of 32. But that is what this sum would converge to, is 32. So this is how you can get a finite answer for an infinite geometric series. And keep in mind, this only works for an infinite geometric series. If we had an infinite arithmetic series, we'd have no hope of being able to solve it. It would just diverge. Okay, let's do another one here. We have 9 plus 6 plus 4 plus, what do we have next? 8/3. And it just keeps on going and going and going. We have another infinite series here, 9 plus 6 plus 4 plus 8/3 plus, it goes on till kingdom come. First thing we need to see, what is the common ratio? So take your second term, your a sub 2, divided by a sub 1 to get your common ratio. Well, that's 6 over 9, which reduces to 2 over 3. Your common ratio is 2/3, which is definitely less than 1. So yes, we can take the sum of this series. We will get a finite answer. So the common ratio is 2/3. Now, our first term is 9. That's our a sub 1. That equals 9. So now we have an ability to take the sum. So the sum from n equals 1 to infinity of our a sub n, which would be 9, our a sub 1, times our common ratio of 2/3 to the n minus 1 power, is going to equal our a sub 1, which is 9, all over 1 minus our common ratio of 2/3. So this would equal 9 divided by 1/3. We just have a complex fraction, so this would be 9 over 1 times 3 over 1, which means the sum of this series is going to converge to 27. So the sum of this particular series will actually converge to 27. All right. let's see, we have 3 minus 1 plus 1/3 minus 1/9 plus ... So we have 3 minus 1 plus 1/3 minus 1/9 plus ... So we have an infinite alternating geometric series. What is our common ratio? It should be plain to see it's negative 1/3, right? The common ratio is negative 1/3. If I take the absolute value of negative 1/3, I just get 1/3, which is less than 1. So yes, we actually can evaluate this since the absolute value of this ratio is less than 1. Now our first term is 3, that's our a sub 1. So we can now put this into the format where we can find the sum. So the sum from n equals 1 to infinity of our a sub n, which will be a sub 1, which is 3 times our common ratio of negative 1/3 to the n minus 1. There's our sum. That's going to equal our first term, a sub 1, which is 3 all over 1 minus the common ratio of negative 1/3. So this is going to equal 3 over 1 plus 1/3, which would equal 3 over 4/3. Now we just have a complex fraction. We'll invert and multiply. You'll have 3 over 1 times 3 over 4, and you end up getting a sum of 9/4, which would give you 2 1/4, or 2.25. So the sum of this series converges to 9/4, which is 2 1/4 or 2.25, however you want to write it. Let's see, we have negative 6 plus 5 minus 25/6 plus 125/36 minus ... So we have another infinite series here, negative 6 plus 5 minus 25/6 plus 125/36 minus ... This just goes on infinitely. Let's find the common ratio. The common ratio, take 5 over negative 6, you get a common ratio of negative 5/6. Alright, so your common ratio is going to be negative 5/6. Take the absolute value of that, you get positive 5/6, which is less than 1. So yes, we do have a sum for this. In our first term, a sub 1 equals negative 6. So a sub 1 is going to equal negative 6. Now let's go ahead and set up the sigma notation so we can take the sum. This will be the sum from n equals 1 to infinity of our a sub n, which would be our a sub 1, which is negative 6, times our common ratio of negative 5/6 to the n minus 1 power. So that formula is a sub 1, which is negative 6 all over 1 minus our common ratio of negative 5/6. This is going to turn into negative 6 all over 1 plus 5/6, which would end up equaling negative 6 all over 11/6. Common fraction, we invert and multiply. You'll get negative 6 over 1 times 6 over 11, which would end up giving you negative 36/11. So this sum will converge to negative 36/11, which would be negative 3 and 3/11. So yes, you can even get negative answers too for your series. Alright, so that's it for putting these into sigma notation. Now for the rest of these, we're going to be given the sigma notation, and we're going to see if we can even find the sum. So we have the sum from n equals 0 to infinity of 10 times 4/5 to the n. So we have the sum from n equals 0 to infinity of 10 times 4/5 to the n. Well, in the parentheses is your common ratio, okay? Your common ratio of 4/5 is definitely less than 1, so we do have a prayer finding the sum of this series. A sub 1, if you, in this case, is actually going to be a sub 0. We'll just put a sub 0 in for a sub 1. It follows the same spirit. It's always really your first term divided by 1 minus r. A sub 0, that's going to be just 10. So now we can find the sum. The sum is just going to equal then our first term of 10 all over 1 minus our common ratio of 4/5. Well, that's going to equal then 10 all over 1/5, which would give us 10 over 1 times 5 over 1, which would put us at a sum of about 50. So this infinite series will converge to a sum of 50. And I got more. Alright, we have the sum from n equals 0 to infinity of 6 times 2/3 to the n. First thing is look at your common ratio, which is inside the parentheses. Your common ratio equals 2/3, which is definitely less than 1, so yes, we can apply the sum formula. It will work. Your a sub 0, which is your first term, is going to be 6. So now we can go ahead and apply the sum formula. So the sum is going to equal my first term, a sub 0, which is 6, all over 1 minus my common ratio of 2/3, which would equal 6 over 1/3, which would turn into 6 over 1 times 3 over 1, making the sum of this infinite series converge to 18. So I end up getting a sum of 18 for this infinite geometric series. All right. We have 5 times negative 1/2 to the n. So the sum from n equals 0 to infinity of 5 times negative 1/2 to the n. Well, our common ratio is negative 1/2. If we take the absolute value of negative 1/2, we get positive 1/2, which is less than 1. So yes, we can find a finite answer. Our a sub 0, which is our first term, is 5. Now we can go ahead and apply the formula. So the sum is going to equal our first term of 5 over 1 minus the common ratio of negative 1/2, which is going to equal 5 all over 1 plus 1/2, which would end up giving you 5 over 3/2, which would give you 5 over 1 times 2/3, which would give you a sum of 10/3. So the sum of this series would converge to 10/3 or 3 1/3, however you choose to look at it, 10/3 or 3 1/3. All right. So now we have the sum from n equals 0 to infinity of 9 times -2/3 to the n. Well, our common ratio is -2/3. Take the absolute value of that -2/3, it's 2/3, which is less than 1. So yes, we can find a finite answer. Our a sub 1 will be that, or a sub 0 in this case would be 9. Now we can go ahead and apply the sum formula, which would equal our first term of 9 all over 1 minus our common ratio of -2/3. Well, that's going to equal 9 all over 1 plus 2/3, which would equal 9 all over 5/3, which would turn into 9 over 1 times 3/5, which would really give you 27/5, which would end up giving you 5 2/5, or 5.4 for the sum of this series. All right, let's see here. Now, what if I gave you something like this? This is definitely a geometric series. You have the sum from n equals 1 to infinity of 2 times 7/3 to the n minus 1, okay? Well, what's your common ratio? Your common ratio is 7/3. Well, here's the problem. 7/3 is greater than 1, right? That means this is going to diverge. This will just keep going to infinity. So we actually have no finite answer to this. This will just keep going up infinitely and infinitely since our common ratio is greater than 1. Now we could take a partial sum if we said we were going from like 1 to 5 or 1 to 20 or really any finite number we could do, but we can't find an infinite sum because the common ratio is greater than 1. If it's greater than or equal to 1 even, you have no finite answer. Another one like it, you have the sum from 1 to infinity of 8 times the quantity of 5/3 to the n minus 1. So you have the sum from n equals 1 to infinity of 8 times 5/3 to the n minus 1. This is why, again, I say take your common ratio first. Your common ratio is going to be 5/3. Well, 5/3 is definitely greater than 1. So this series is going to diverge because it's just going to keep going up and up infinitely and never settle at a finite answer. So we don't actually have an infinite sum. That's why it's good to check your common ratio first so you don't waste your time. Now here's some good ones. Sometimes you'll even see these in decimal form. So you have the sum from n equals 0 to infinity of 10 times 0.11 to the n power. What's your common ratio? Your common ratio, of course, is going to be 0.11, which we know is less than 1. We know this infinite sum is going to work. If I were you, though, do yourself a favor, convert this to a fraction. The 0.11, we can convert that to 11/100ths, right? It's going to make your life so much better when you try to take the sum. Now your a sub 1 is definitely, or a sub 0 in this case, is definitely going to be 10. Now let's go ahead and find the sum. So the sum is going to be that 10 all over 1 minus 11/100ths, which is going to equal 10 all over 89/100ths, which would give you 10 over 1 times 100 over 89, which means the sum of this series is going to converge to 1000 over 89. So the sum of this series converges to 1000 over 89. And if you want to get a decimal approximation, feel free, but I don't think it's necessary. I only have 3 more. Alright, so we have the sum from n equals 0 to infinity of 5 times 0.45 to the n power. Well, first thing, what's your common ratio? That's 0.45, which is definitely less than 1. That's going to work, but let's convert that to a fraction. That's 45/100ths, which when we simplify that, you should end up getting 9/20ths. So your common ratio in fraction form is 9/20ths. Now your first term, your a sub 0, is going to be 5. Now we can find the sum of this series, which is going to then end up equaling our first term of 5 all over 1 minus your common ratio of 9/20ths, which is going to equal 5 over 11/20ths, which would end up giving you 5 over 1 times 20 over 11, which would end up giving you 100 over 11, which is a bit less than 10. That would actually be 9 and 1/11th if we're being precise. You get 9 and 1/11th, that's what 100 over 11 is. So a little bit greater than 9 would be your sum. Alright, 2 more. We have the sum from n equals 0 to infinity of -3 times -0.9 to the n power. So we have the infinite sum from n equals 0 to infinity of -3 times -0.9 to the n power. Well, our common ratio equals -0.9. If we take the absolute value of that, we get 0.9, which is less than 1, so we know we can find a sum, a finite sum, but let's convert this into a fraction. That would end up being -9/10. This is going to make our lives a lot easier. Now a sub 1 is -3, or a sub 0, I should say in this case, is -3. Now we can find the sum. So the sum is going to equal my first term of -3 all over 1 minus my common ratio of -9/10, which is going to end up giving me -3 all over 1 plus 9/10, which would end up giving me negative 3 all over 19/10, which would give me negative 3 over 1 times 10 over 19, which would give me a sum of negative 30 over 19, which would be about negative 1 and 11/19. You get about negative 1 and 11/19 for your sum, negative 30/19. I got just one more. Alright, we have the sum from n equals 0 to infinity of negative 10 times negative 0.2 to the n power. Well, our common ratio, of course, is negative 0.2. Take the absolute value of that, we end up getting 0.2, which is less than 1. So yes, we can definitely get a finite answer for this. So let's convert this into a fraction. That's going to end up being negative 1/5 for our common ratio, which means our a sub 0 term, our first term, is negative 10. So let's go ahead now and find the sum. So the sum is going to equal my first term of negative 10 all over 1 minus my common ratio of negative 1/5, which would give me negative 10 all over 1 plus 1/5, which is going to give me negative 10 over 6/5, which would give me negative 10 over 1 times 5/6, which would end up then giving me negative 50 over 6, which would simplify then into negative 25 over 3. That would be my sum, which would end up being negative 8 1/3. That's what that would converge to, is negative 8 1/3. You get which is negative 25/3. Alright, so that's it for infinite geometric series. Next lesson we're going to do a type of proof that I haven't taught before called mathematical induction. That's a very big staple of precalculus, and if you go in to take discrete maths or other theoretical math courses after this, mathematical induction is a very big type of proof that you do. So I hope everyone has a great day. Take care.